So imagine yourself in your 80s, 90s, and 100s. What does life look like? Does it have meaning? Does it have purpose? And are you living your life on your terms? Welcome to the Future Age podcast, brought to you by the Future of Aging team at SE Health. I'm your host, Zannat Reza. We used to be lucky if we lived to 70, and now many kids born today will make it to 100. And in this series, we explore creative solutions and reimagine what life as we get older can look like. Because even though we're getting older, this is bigger than just us and our personal experiences. In this series, we're exploring the possibilities. We're taking a look at how we can shape the future of aging for all generations through policy, innovation, and much-needed cultural shifts. Now, 3D printing has been all the rage over the past several years. Think auto parts, surgical tools, toys, and even jewelry. So as this technology gets more sophisticated, it's starting to be used on a much larger scale, like 3D printed houses. This idea is slowly gaining momentum with projects sprouting up around the globe. For example, Mvule Gardens in Kenya is a neighborhood that now consists of more than 50 3D printed houses. It's actually Africa's largest affordable housing project. And in Dubai, they're aiming to have 25% of their buildings created by 3D printing technology in 2030. While that may sound ambitious, they have a plan in place to try and reach that goal. And so maybe it's time for Canada to take a closer look at developing its own 3D printed housing plan to address the housing crisis. Among the G7 countries, Canada has the lowest supply of housing for every 1,000 residents. And this shortage means that houses are much more expensive. It's that classic supply and demand equation. And what's shocking is that nearly 250,000 Canadians are experiencing homelessness, a growing number of whom are adults over the age of 65. According to the 2021 census, 10% of Canadian households, that's 1.5 million, are in what's called core housing need. In other words, they have nowhere to go in the marketplace. It's estimated that 65% of older Canadians are in the missing middle of housing options, meaning that they have few or no housing options that meet their financial, medical, functional, and personal preferences and needs. So in addition to being affordable, age-friendly housing needs to allow for social interactions and services within the community. And of course, be designed to adapt to our changing needs as we get older. So given that a 1,200 square foot 3D printed bungalow can be customized easily and built in about a week, which is faster than a traditional wood-framed version, which can take 6 to 10 months, are 3D printed houses both the answer to affordable housing and to house a growing population of older adults? So I spoke to Ian Arthur, president of Nidus 3D, a construction company in Kingston, Ontario that specializes in building houses using 3D printing technology. We talked about how they're built, its benefits to both an aging population and in dealing with climate change, and how we can accelerate the process to build more and faster. Here's some of our conversation.
In relation to aging, a very good project for us would be a lot of single-story buildings fairly close together, kind of as a campus style, because we can move very rapidly and get to a place where we're able to probably build 1 to 2 units a week.
And how large are these units?
Honestly, any size you want. Right now, our limit is the 40 by 40 for the printable area. So, 1,200 square foot bungalow.
Have there been other conversations that you've had on age-friendly housing?
One of our first investors is building 4-plex units that all have their own ground-level entranceways, single-story, 2-bedroom, specifically for the aging population. His design is a little bit bigger than printable area that we're able to execute in, but that approach is something that we're very well geared to do. I think there's huge potential of this technology for building aging-friendly homes. We can make wide hallways, again, in the similar way where we can add extra insulation. It's just a couple clicks on our model on the front end to widen a hallway and build that so it's accessible. And same with the doorways. There's no real cost difference to do the wider accessible doorways. So there's advantages like that. We have rounded corners, again, to make movement through the house easier. It is a structural component. So if you need sort of equipment added into a house for aging in place, it's very feasible to mount and hang stuff off of the printed concrete in a way that would be very difficult to do with traditional construction.
Well, in talking to Ian, this all sounds really promising. But how exactly do you build a house using a 3D printer?
Start with a picture in your mind. I think most of us, or many of us at this point, have seen a little 3D printer. We've seen them in videos. Local libraries have them sometimes. Schools and universities tend to have them. You've got your little square box and there's a little print head that sits in the middle of it, and it puts down layers of filament, plastic or metal or wood sometimes, and then just scale that to be big enough to do a house. It looks very, very similar, just much, much, much bigger. The printer that we have right now, the printable area is 40 feet by 40 feet by 30 feet tall, approximately. And then we're about to onboard a second printer that extends the length of that building up to 62 feet. And then instead of the placement of, plastic or metal, we're printing with concrete. And the printer starts going, and layer by layer, you'll start to see a building slowly but quickly in the realm of building buildings.
So Ian assures me that printing concrete is just as strong as a cinder block or any other concrete structure. Just to be sure, they conduct tests by sending samples to labs in partner universities, where they crush the samples to measure their strength. That's reassuring, but what about building codes? Do they exist for 3D printed houses?
Not yet, but they are coming. There's a group developing the ASTM and ISO standards, so International Standards Organization for 3D printing. Our lead engineer actually sits on the board of the group developing the first international standards for 3D construction printing. They've got the initial set of documents out for public consultation right now, and we should, within the coming months, be able to see the final documentation of that. That's the first step. Then national building codes have to start to incorporate those similar or standards into it, and then we'll see provincial building codes incorporated into it. So it's a long path. It's definitely going to take us a while to get there, but we're moving towards it, and I'm confident that we'll see it happen sometime in the near-ish future. In the meantime, the approach is to use engineers and engineer stamps. So if you have a masonry structure and you go get it stamped by an architect and stamped by an engineer, that meets the threshold requirement to be allowed to build.
Now let's talk about money. How do 3D printed structures compare to the cost of building and maintaining regular housing?
We're a little bit more expensive than a wood frame house still, but we see that inverting very, very quickly, where this will be one of the cheapest forms of construction that we can possibly do. There's a lot of variables in how you would cost it out. It changes so dramatically based on the size of the project, the type of building that we're doing. There's fairly set cost per square foot for wood structures. They don't really change based on the building design. We can dramatically change cost per square foot based on the building design. How many of them are going on one site? So if we're moving a printer onto a site, we definitely want to be putting up more than one structure. Our ideal minimum would be 10 buildings with however many units within those 10 buildings.
And in case you're wondering how much a 3D printer large enough to build a house actually costs,
it's about $2 million per printer for the printer and all the supporting equipment. It is a much more capital intensive investment on the front end, and then the efficiencies start to get delivered after that. So it's not cheap. I think the cost will come down.
Nidus 3D also sells 3D printers. So if you've got $2 million laying around, you know who to call. Ian shared other benefits of 3D houses. They can withstand extreme changes in weather brought on by climate change, and they also have lower carbon emissions compared to traditionally built houses.
They're definitely stronger. You're building a home in concrete, it's going to be more climate resilient than a wood equivalent for sure, not just against tornadoes. There's a lot of interest in places like Florida or anywhere where you would get a lot of flooding. Ideally, you don't want a home to flood at all. If it does flood, the concrete's going to be easier to repair and have as a resilient product than with a wood house. So I think the buildings are exactly the sort of buildings we need to be looking at for the future. We'd like our homes to be multi-generational, 100-year homes, minimum. They need to be climate resilient if they're going to last that long, but also not having to rebuild. I mean, there's a huge amount of embodied carbon every time we put up a new structure. The construction sector represents a huge portion of our carbon emissions. So if we're building assets that can last a lot longer, we're going to need to build fewer of them in the long run.
Climate resilient, potential for cost savings. Why aren't we building more 3D homes?
The technology truly is in its infancy. We are doing every project we've done so far. We've done something that no one else in the world has tried to do. Printing of components to expand the size of the building. We printed components in what was ended up being the living area of the primary part of the building. And then once we were done, craning them out and attaching them to the side of the structure to make it overall bigger. No one had ever tried that. Multi-story structures in concrete, again, all of it is brand new. And it takes a while to figure out how to use the technology well, figure out how to scale it. We have 2 printers. We've got another group that we're working with that's purchased a printer as well. Those are the only 3 large printers in Canada. We need to get to a place where we have thousands of these working all building season long. And then we'll start to get to a place where we're impacting the housing supply in a really, really significant way.
Other than having not enough printers, there's bureaucracy.
We can't eliminate so much red tape as to allow unsafe structures to go up. There's the safety side of it, and then there's also the environmental side of it. A lot of the obstacles are there for a reason. Don't build on floodplains, species at risk, all of that stuff is tremendously important. We have to find a way where we can maintain those safeguards, but we expedite the actual application of the building. If we deem a location is safe and we can go into it and it's not harmful, then we need to get the process faster. Municipalities have a lot of work to do there. I would say they dramatically need to transform how they approach sort of zoning, site plan, and building permit issuance. Our experience has been start early and have an open dialogue. I don't think any of these groups are actively trying to stop people from putting up buildings.
So, Ian, what could help accelerate more 3D printed houses?
Getting more people interested in it, getting developers interested in it so that they're looking at this as an option. It's a bit of a fine line. We got to ride the line with our own capacity and our ability to deliver. We're not in a place where we're going to be able to do 1,200 homes or 1,500 homes this summer. I hope that other people seeing the success that we've had in 3D printing will want to start looking and moving into this. There's no way we're going to be able to do this all on our own. We know we need other players in this sector pushing the envelope, thinking of stuff that we haven't thought of, helping scale it, bring it to market in a really meaningful way. From a policy standpoint, the formalization of those building standards and building codes is going to be really important. When that trickles down to municipalities, they know exactly what questions to ask and what to look for when they're approving a 3D printed structure. That would be huge.
So it sounds like we're at the start of something exciting. Not only can 3D printed houses withstand variations in climate, they can also last over 100 years and almost be built overnight. But what's needed is more printers and less red tape to accelerate the production of 3D houses. And maybe this will pave the way for more affordable housing that can be customized to be age-friendly. We're going to shift gears for a second because we're curious about the future and your thoughts on the future. So in 10 words or less, finish this sentence. The future of aging should be...
How about just fun?
I love it.
Yeah, like it should, it should be it should be fun. It shouldn't be something to fear.
That's great. And I'm guessing this is also going to be part of your answer for we're time traveling. Here's Ian, you're 100. What does your ideal life look like?
I hope it's always interesting. I really do. I hope that I get to work on stuff that's challenging. I remember it was a few years ago now, Jean Chrétien had just released his newest book, some memoirs or something. And I don't remember what age he was, but he skipped onto stage and was cracking jokes and had a great time. And I was just like, God, I hope I'm that. I hope I'm writing or doing something or contributing in a meaningful way. And I hope I do it with a sense of humor and that, everything stays in place long enough in terms of functionality to make that feasible.
I love that answer. I think that's great. Thanks, Ian, for dropping by. This has been a real pleasure. Thanks for joining us for this episode. To learn more and for transcripts, go to thefutureage.ca. Listen to new episodes by following us wherever you get your podcasts. And if you're liking our podcast, leave a review on Apple or Spotify, and be sure to share it with your friends, family, and colleagues. The Future Age is brought to you by SE Health, a not-for-profit social enterprise whose purpose is to bring hope and happiness to the lives of Canadians. It's produced by the Future of Aging team and Podium Podcast Company. For more information, visit thefutureage.ca.